Hi, good morning to all of you. My name is Prashant Kumar. I'm a mathematics faculty. For the last 4 years, I have been teaching math for the JEE student. So today we are going to discuss the conic section. This chapter has a huge scope in the exam for the JEE portion. It is a weighted topic. Conic sections are the core part of the coordinate geometry, which itself carries a significant weight in the JEE Advanced. Around 20 to 25% of math question in JEE Advanced and 3 to 4 questions in mains, which comes directly from this portion. Types of question which are generally asked is first is the formula based question. Second is a locus based, tangent, normal based. Third is application based, merging this topic with the other portion. Suppose the area enclosed by conics, combining it with integral portion. Other is a combining with the vector and 3D portion. So in JEE Advanced, if we see the questions of the JEE Advanced, it is quite a multi-layered question. It is not directly formula based for the advanced. These three portions, the formula based, locus based, and application based, these are for the mains portion. But for the advanced portion, it is more like a multiple concept has been used to frame one questions. If we go now definition of this conic section, how do we define this conic section? Definition: it is a locus of a point that moves in a plane such that its distance from a fixed point to its distance from a line is in some constant ratio. So it is nothing but a ratio of a distance from fixed point to distance from fixed line is in some constant ratio, which we define as something called a E. E is nothing but the eccentricity. E we define as a eccentricity. If we see this definition geometrically, we have taken a fixed point a comma b. We define this as S. We have taken a fixed line as Lx plus My plus n equals to 0, and we have taken one variable point which is P, whose coordinate we have taken x comma y, and intersection of this perpendicular line from P to this line is M. So we define this ratio as SP divides by PM equals to E. One thing which we have to keep in mind in this definition is we do not reverse this ratio. We can't reverse like Pm by Sp is not equals to V. We always take this definition is ratio from a fixed point to distance from a fixed point to distance from a fixed line is equals to E. Now everything is played by E. If if E equals to 0, the shape or the curve this equation will trace is of circle. If E equals to 1, the curve traced by this equation will be of parabola. If E is less than 1, then the curve trace will be ellipse, and if E is greater than 1, the curve will be traced as hyperbola. Uh, Parabola Sp by Pm equals to 1 implies that Sp equals to Pm. So distance from a fixed point to its distance from a variable line is equals. So distance, if I have taken a comma b, this is x comma y. So Sp will be x minus a square plus y minus b square of under root. And Pm will be Lx plus my plus n modulus divided by under root L square plus m square. So if we equate this both the distance, we get the equation of the parabola in something form of x minus a square plus y minus b square equals to modulus of Lx plus my plus n divided by under root square L square plus m square. After solving this equation, we will get something in the form of uh, second degree non-homogeneous equation, like something to the square plus something y square plus something xy plus something x plus something y plus c equals to 0. So it will be in the form of some like ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equals to 0. This is a second degree non-homogeneous equation. Non-homogeneous equation. If we find the determinant of the delta, if delta is not equals to 0, then it will give us a conic section. So now comes what is delta. Delta is a determinant of A, H, G, H, Z, B, C, F. If the value of determinant is not equals to 0, then we are definitely going to get the conic section. Conic section on the basis of the value of the uh, determinant of this delta. Now, case 1, when h equals to 0 and a equals to b, we are going to get a circle. Case 2, when h square equals to ab, we will get a parabola. Case 3, When h square is greater than AB, we will get a hyperbola. Case 4. When h square is less than AB, we will get ellipse. So for the parabola, in, we have defined two conditions for parabola. One is SP divides by PM is equals to 1, and other is when h square equals to AB. The standard type of parabola we studied in our courses. The first one is of the form of y square equals to 4x. The shape of parabola will be something in the form of this. Its focus or the fixed point will be a comma 0. Its directrix, which is a fixed line, will be x plus a equals to 0. The coordinate of this perpendicular will be minus a comma 0, and the vertex will be at origin. This is S, this is P, this is perpendicular distance. So by our earlier definition as P equals to PM, we take the P as a uh, H comma K. So SP will be under root H comma A square plus K comma 0 whole square. PM will be H plus A modulus divided by under root 1 square plus 0. So by definition this will be under root H minus A square plus K square equals to modulus of H plus A divided by A. Squaring both sides, H square plus A square minus 2AH plus K square equals to H square plus A square plus 2AH. If I cancel on this H square both side and A square both side, we will be left out with K square equals to 4AH. Replace H with X and K with Y to get locus equation. So we will get the equation of this parabola will be y square equals to 4ax. And this is the first standard parabola we uh, have studied.